Good morning, everyone. This is Jim Chastain, and we're doing a refresher feature this morning that's going to be relatively short and sweet, and hopefully you'll be able to get some valuable information, especially if you're a new user to EasyPower and are trying to take advantage of the tools to the maximum effect. Our agenda today is focused on basically two areas. During arc flash calculations, under guidance from both IEEE and the NFPA, there's some specific scenarios that are required to be considered as you're required to determine the worst case situation for calculating incident energy and the arc current for any given fault on a bus. Well, EasyPower has features that help with this process, and we're going to cover those here briefly. And then as we move out of that, we're going to go into discussion of EasyControls and how valuable a little bit of time and utilizing some of the EasyControls capabilities can be in not only your productivity, but the usability of your one line as you complete it. So as I mentioned, there's basically three scenarios that are suggested or required depending upon the document. Two specifics are included in IEEE 1584 and NFPA-70E. 1584 says it's required to compare the incident energy in your system with and without motor contributions to determine the worst case scenario between those two events. NFPA-70E says that you need to compare 100% arc current trip time on the protective devices with the 85% arc current trip time and use whichever is worse as you're calculating incident energy. And then finally, a less specific but more generic and very often more restrictive is when you're considering complex systems that have multiple voltage sources, cogeneration, standby supplies, and cross connects and cross ties. There's the requirement to compare each of these configurations if the system will be spending any time running in that mode to verify that the arc flash incident energy that's being calculated and labeled for is considered in your labeling scheme. So let's jump into the tools and talk about each of these briefly. All right, so this is actually an example that are in your sample file if you have the tools installed. This is called Smart PDC. Very often we use it to demonstrate how to coordinate between adjustable breakers and very large motor loads. So if we want to compare or generate scenarios and do a comparison between system calculations with and without the motors, you follow the following process. As I'm in Database Editor, and I want to look at my scenario manager, and as I open scenario, it's going to ask me to save the one line before continuing. Let's go ahead and do that, and that'll generate the base case. And so you can see here that I have no named scenarios, and so what we're going to do is create a couple and do a comparison. With the mouse in a free space of the drawing surface, if I right-click, one of the, actually third from the bottom, optional choices is to include motor contribution. So I'm going to select that, so you can see now we have it selected. I'm going to go back and store the scenario as with motors. And now as we calculate incident energy or look at the branch currents, you can see that we have motor contributions from each of these loads, and some are fairly substantial, maybe 5 to 8% of what the utility load is or the bus load is on max current. All right, now let's go back, change it to without the motors, create this scenario. So I'm going to store scenario as and save this. And now let's go ahead and look at it in calculations and see make sure it's doing what we want it to do. All right, so we're faulting the bus. We're just looking at half-cycle currents. And if this bus is faulted, you can see that there's no motor contribution coming back from any of these heavy loads. So in effect, the two scenarios do precisely what we're trying to do. And you can see in a more complex system, even as we go to incident energy, it's not that easy to make a one-to-one comparison. And so the value, and because it's all in one step, is to be able to go to the database editor now that we've created the scenario manager, create a scenario comparison report for Arc Flash. And let's don't change anything for now. Use the basic format for the report. And the tool presents now a by bus incident energy calculations where we're showing Arc Flash boundary, in fact all the calculated results from Arc Flash hazard report, and now it's showing us which the worst case scenario is. And in one case the base case is, although obviously this is not a valid comparison, it looks like with motors though is pretty much the worst case, at least in this particular circuit. So what we can do is show all scenarios, the worst scenarios, and then from there we can print the labels directly for the worst case, or we can go through and select from our entire list the labels that we want to produce. And again, now that we have the label production is pulling the data from the same Arc Flash hazard report format, but now it's only pulling it from the base case, the calculation for each of the base cases. And you can see as we scroll through the buses that it's giving us exactly what was on that report. All right, so let's consider something else. While we're here, if you look at, one question might be, what's the result of having this motor hang directly on the bus? And so the question is, does this breaker actually, as we're doing coordination, it obviously doesn't do anything to protect the incident energy on this bus. What does it do, and what kind of protection does it do if we're calculating or considering incident energy actually on the motor itself? And so to look at that, if it's something that we have a concern about and we have knowledge that there's a need to work on this particular motor at the plant with energy applied, one way to deal with that is to disconnect it, actually add a bus, an intermediate bus. Turns out there was no bus required because of the motor being the load, but now by taking this approach, we can go in, fault this bus, and short circuit. And we're obviously having, let's go back and add our motor contribution. So the significance here is, although the total current on this bus, if a fault were here, is 42,000 amps, you can see the net on this bus faulting is only 40,000 amps, with 2016 coming back from the motor. So the effect is to actually reduce the amount of current during a fault that this breaker will see. And so when we go and produce incident energy just for that one bus alone, you can see that it may be quite a bit less if this is where we're going to be doing the work, because of the ability to include this particular breaker settings, as opposed to when we didn't have this bus in the area. Just something to consider when you're trying to look at constraints in Arc Flash calculation and mitigating energy, in that the energy on this particular bus actually could be decreased as we remove loads from the bus, and that would be a procedural call, if you will. You can see that the arc flash boundary is decreasing. It might be a procedural call that if we had to work on this bus while it was still electrified, by reducing the loads on it, might bring the PPE down, or the incident energy down low enough that we could work on it with less danger to personnel. Okay, so that's just motor contribution. Let's close this one out. Again, this example is in your sample file under Smart PDC. Now, the more common case, I guess, not necessarily common, but the case that people, I think, have a little bit more concern about, or headaches with, is a more complex system, and very often, well, I guess I gotta go find my other example. It's when you do have a complex system that ends up having several different configurations, and it's not intuitively obvious what the most dangerous situation is, or where the most arc flash incident energy is created. And very often you'll have dual utility feeds or cogeneration situations with tie breakers to be able to isolate different parts of the system if on a power outage, or an ATS involved with standby generation. Kind of two things we're looking for. One is just to start with the incident energy calculations. So here from our database editor, we want to go in and look for the scenarios that we've generated, and you can see we've labeled them in such a way that it's pretty understandable what's going on. Here with the cogen only and the tie closed, cogen only, tie open, panel B3 on standby, utility and cogen both with the tie closed, tie open, and the utility only with tie closed. And while I was doing this presentation one time, I was asked, well, what's the limitation on Scenario Manager from EasyPower? How many scenarios can it address at one time? The answer is it's unlimited, because we are, although as we're calculating this report, we're actually going through every permutation of those breakers that can be derived. We're not redrawing the whole system, so it doesn't take that much computer memory, and consequently the whole case can be literally reconfigured and calculated just as fast as we did this report. So now you can see we're looking at all of our scenarios and the results, and the difference, for instance, for MCCA2 is a matter of almost a whole calorie difference in incident energy between what was on the cogen only with the tiebreaker closed and the other scenarios involved. Now, and so we can go ahead and walk through and produce the labels for these cases. The other advantage and the other thing to consider is, when you're looking at the scenarios, is that what is happening to equipment duty, because now if we're having different stresses, different energies on each of the buses, is that going to overstress any of the equipment, because we have the duty ratings that need to be calculated for each bus, and consequently we're able to generate that literally with a one-button click. And as I mentioned before, we can produce equipment duty and look at essentially the most restrictive headroom and decide whether or not we need to make adjustments for our system duty-wise. It may be that that we could be over-dutied in situations that are not that frequently run. All right. So now let's. So any questions on Scenario Manager? By all means, send them to me on the chat line, and we'll try to get get to them here at the end of the session. All right, then the other area that I wanted to spend a little bit of time very briefly is that of EasyControls. You'll notice that we have, in my particular installation, I have a sidebar here that is an auto hide mode right next to the tool equipment menu, and I can pin it to leave it out. What it allows me to do is to actually take advantage of several key advantages to maneuver around a very large file much easier. Okay, so let's say we have a very large system, and if I wanted to move from one edge to the other or find a particular piece of equipment, we got a couple choices. First of all, let's say I'm looking for hydro pump motor 3. Well, I would go to the find motor, and I could go down and find hydro pump motor 3, and the tool brings me to that and highlights it in green. On the other hand, if I want to be able to jump back and forth between different focuses, EasyControls allows me to go to named views and jump, let's say, back and forth between a previously set focal point and a new one that I may want to consider at least save. And so here I've focused in on JB Mod 2, and from wherever I am in the system, it allows me to jump there with the same focus and pan settings. Likewise, if I wanted this particular area to come back to, let's call it SAW 20 amps, I'd create a new named view and call it SAW 20 amps, which may have some meaning in my vernacular. And now as I come back to it, it'll give me the same focus. Okay, likewise, if I want to isolate a particular piece of equipment on its own sheet, I can highlight it, go to the diagrams, create a new sheet, and EasyPower will now put that element here on a special or separate sheet for me. And if I so desire, I can include the schedule and then be able to include this in a report that includes company logos and date and time and the like. And these can be carried, these are carried with the file, and these are, so obviously these are other panels that I've isolated and wanted to bring to focus. So this is a function of the drawings in EasyControl, and then as I go to the name views, I can save specific areas of zoom and pan settings to be able to jump to different parts of the system as I go there. So now there's one other thing to consider, and this goes to the planning side of things, and that is, rather than just sit down and start drawing a one-line diagram, very often it's easier, or worthwhile at least, to consider what the ultimate goal is. And what we're looking for is, for instance, let's say we have a ring set up, and in this case our high voltage system, our medium voltage is distributed in a closed ring, and our ultimate distribution panels and subsystems will be much better illustrated if I can isolate them and then put them down in a section of the one line. So to do something like this, after I've walked through and considered, okay, this will allow me to control where my medium voltage is distributed. Now as I hook up the sub panels, I can, as I characterize this particular cable that goes to my distribution transformer, I can say don't show the entire line, and I'm not going to worry about it being complete right now. And now I can move that down to a subsection of my one line. It's still on the one line, and in fact I may want to ultimately take this and put it on its own drawing sheet like this, and all all the while basically keeping a coordinated view of my, my whole one line. So the point being, in this particular case, we want to be able to verify we can produce energies down to the lighting panels and the single phase panels. I'd want to walk through this scenario actually before I started constructing very much more of the details to make sure that my end result, which is to show the single panel energies, is going to come from this organization. And so we'll actually cover that in a future refresher. All right, that pretty much concludes the topics I wanted to cover. What we've seen is to be able to improve your organization of your one line and to be able to jump around in a very big file, use name views, and then utilize the separate drawings to isolate parts of the line for printing and reports. So with that, I will close the session out. Anybody that has questions, more than welcome to send them in on the chat line, and we'll spend a few minutes answering them right now.